Good morning. Today we'll discuss new topic relations and functions. Already we completed theory one. Now we'll discuss synopsis of this relations and functions. Okay, we'll start with some basics. First, ordered pair. What is ordered pair? Okay, try to understand. Ordered pair. Capital A comma capital B are any two sets. A belongs to A, B belongs to B, then A comma B is called ordered pair. This is ordered pair. Capital A, B are any two sets. A belongs to A, element A belongs to capital A, and element B belongs to capital B. Then this is called ordered pair. Next, equality of ordered pairs. Equality of ordered pair. So when two ordered pairs are equal, that is, see here, A comma B is one ordered pair, C comma D is another ordered pair. When these two are equal, it is possible only if A equal to C, B equal to D. Then only we can say the two ordered pairs are equal. That is, first coordinate equal to first coordinate, second coordinate equal to second coordinate. Then only we can say the two ordered pairs are equal. Next, Cartesian product. Cartesian product. See here. Capital A comma capital B are any two sets. The Cartesian product of A and B is denoted by A cross B and defined as set of all ordered pairs from A to B. So A cross B, it is the symbol. A cross B, cross product is symbol. No? Cartesian product, you can say Cartesian product. A cross B is a Cartesian product. It is defined as set of all ordered pairs from A to B. See, A cross B defined by set of all ordered pairs. Set of all ordered pairs. Okay, that is A cross B is equal to what are this? What are there now in that A cross B? There is ordered pair A comma B. Here, what is A? What is B? A belongs to first set, B belongs to second set. This is the definition of Cartesian product. Let us check. See, A is equal to 1, 2, 3. B is equal to A comma B. A equal to 1, 2, 3. B equal to 2. A comma B. Then how to calculate A cross B? A cross B means 1, 2, 3 set cross A comma B. Okay. What is the meaning of cross product or Cartesian product? What is Cartesian product now? It contains all the ordered pairs. So set of all ordered pairs. Ordered pairs means 1 A. First element belongs to first set, second element belongs to second set. First element 1 comma A. Next 1 comma B. Next 2 comma A. Next 2 comma B. Next 3 comma A. 3 comma. This is called Cartesian product. Process of finding Cartesian product. Okay. Now, just observe how many elements of A has 3. How many elements are there in B? 2. So, how many elements are there in A cross B? 1, 2, 3, 4, 5, 6. A has 3 elements, B has 2 elements, then A cross B has 6 elements, 3 into 2. So, remember, this one we will use as formula. Okay. N of A is equal to P. Means number of elements in A is P. N of B is equal to Q. Then N of A cross B is equal to PQ. Means A has P elements, B has Q elements, then A cross B has PQ elements. Check it the before problem. A has 3, B has 2. So A cross B has 3 into 2, 6 elements. Correct? Next, relation. Next concept is relation. A comma B are any two sets. Any subset of Cartesian product. Any subset of Cartesian product A cross B is called a relation from A to. This is definition of relation. What is definition of relation? Simply you can remember any subset of Cartesian product A cross B is a relation from A to B. Before example only I will take A cross B. Already we have written. What is A cross B? 1A, 1B, 2A, 2B, next 3A, 3B. Okay, we got A cross B like this now. Before example. Now I will write subsets now. 1A, it is one of the subset. Next 1A, 1B have taken 2 elements. This is also one of the subset. Next 1A, 1B, 2B, 3B. This is also one subset. Next, I will take one more subset. 3B, 3A, 1B. I'm taking like this. This is also one subset. So there are so many subsets are there. Each subset is a relation from A to B. So this is one of the relation. This one another relation. This is another relation. This is also another relation. All these are relations. So any subset of Cartesian product is a relation from A to B. All these are the relations only, no? Because all these are subsets. These are also relations. Check it more. I will take R is equal to null set. It is also a relation. Why it is relation? Because null set is also subset of A cross B. Null set is also subset of A cross B. Subset is relation. So null set is also a relation. Okay. Next. And if R is equal to A cross B. A cross B is subset of A cross B. So subset means it is a relation. Okay. A cross B is also one of the relation. Null set is also another relation. Especially this relation is called empty relation. This is empty relation. Special name is this is also relation. Especially it has a name, empty relation. This is also relation. I'm taking R is equal to total A cross B. A cross B is subset of A cross B. So A cross B is a relation. This relation is called universal relation. Universal relation. Now, one important point is there. You can remember this for CV. So, n of A is equal to P. N of B is equal to Q. Then, number of possible relations. And then number of possible relations from A to B is, guess what is the answer? It should be 2 power PQ. Have to remember. Number of relations from A to B is 2 power PQ. Why it is 2 power PQ? First of all, what is relation? Relation is a subset of A cross B. Relation is subset of A cross B. How many elements are there in A cross B? PQ. So if number of elements are PQ, then number of subsets are 2 power PQ. So in sets already we discussed it now. If A has m elements, then number of subsets 2 power m. Here also A cross B has PQ elements. Number of subsets 2 power PQ. Okay. Next, domain, codomain, range of relation. What is domain of relation? What is codomain of relation? What is range of relation? See here, R is a relation from A to B. If R is a relation from A to B, then set of all first elements of ordered pair is called domain. Set of all first elements of the ordered pairs is called a domain. Next, codomain. Okay, first we will discuss range. Set of all second elements. Set of all second elements of ordered pairs. Ordered pairs of relation. Okay. So relation contains ordered pairs because relation is a subset of A cross B. A cross B has ordered pairs. So relation also having ordered pairs. In ordered pairs, there are two numbers or two elements are there now. First coordinate and second coordinate. This is only A comma B. This is ordered pair. This is first coordinate. This is second coordinate. So in all the ordered pairs, set of all first elements is domain. Set of all second elements is range. Next, the set B, second set is there now, the total set is called codomain. So set of all first elements domain, set of all second elements range, the total set second set B is called codomain. I will take one example now, you may get some idea. So A is equal to 1, 2, 3. Before example only I will take B is equal to A comma B comma, okay, keep as it is, A comma B. Next, first find out A cross B. 1A. So A cross B means we will get ordered pairs. 1 comma A, 1 comma B, 2 comma A, 2 comma B. Next, 3 comma A, 3 comma B. This is a Cartesian product. Now I will write a relation. Relation is nothing but a subset. Okay, I will take one subset now like this. 1A, 2A, and 3A. So I have taken this is one subset. One subset means compulsory it is a relation. In that relation, I will write domain. What is the definition of domain? Set of all first elements of the ordered pairs of a relation. So these are the ordered pairs in that first elements 1, 2, 3. Set of these three elements 1 comma 2 comma 3. This is called codomain. Sorry, domain. This is called domain. Next, go for range. What is range? Set of all second elements of the ordered pairs. What are the second elements? A. So 3 times is there, nothing but it is already we discussed now. In set, repetition of the elements is not allowed. So we'll get only one element. It is A. Next, what about codomain? Codomain. The total second set. What is the second set? B. A comma B. This is here. I will write one more example. You may get some idea. So, R is a relation from A to B. They define like this. A, B, 1, 2, 3, 4, 5. Here A, B, C, D, E. They define like this. Okay. Next, relation. What is the relation of R? R is a relation from A to B. See here, what are the elements? 1 is related with A. So 1 comma A. This is first element in the relation. Next, 2 is related with A. 2 comma A. Next, 3 is related with B. 4 is related with B. Okay. This is given relation. In that relation, we will calculate domain. What is the definition of domain? Set of all first elements of the ordered pairs in the relation. What are the first elements? 1, 2, 3, 4. 1, comma, 2, comma, 3, comma, 4. This is relation. Sorry, domain. Next, range. What is range? Set of all second elements of the ordered pairs. What are the second elements? A, B, B. So we can write only one time. That is A, comma. This is domain. This is range. Next, codomain. What is codomain now? The total second set. What is the second set here? B. What is B? B contains A, B, C, D, E. Okay. Observe now. Range is always subset of codomain. Generally, range is always subset of codomain. We can do problems also. No? Okay. Next. Function. Next concept. Function. A relation. First, I will write the definition. I will explain. A relation F A to B is said to be function. A relation F A to B is said to be function if every element of capital A has unique image in capital B. Okay? This is the basic definition of function. A relation F A to B is said to be function if every element of capital A has unique image in capital B. See, to become a function, first of all, it should be a relation. First of all, it should be relation. Then only it becomes function. So after, okay, it is a relation. First of all, it is a relation. It should satisfy one more condition. What is that condition? Every element of first set has unique image in second set. Okay? Every element of first set has unique image in second set. I will explain by taking one example. Here A, B. 1, 2, 3, 4. Here I am taking A, B, C, D. Is it function or not? So check it now. What is the definition of function now? Every element of capital A. What are the elements in capital A? 1, 2, 3, 4. Has unique image in capital B. Unique image in capital B. So I am taking 1. 1 is related with A. So A is image of 1. So A has unique image. Is there any image for A? No. So A has 1 has only one image, that is A. Next, go for 2. 2 is also related with A. So A is image of 2. Therefore 2 has unique image. Next, go for 3. 3 is related with B. So B is image of 3. So B has only 3 has only one image. Go for 4. 4 related with C means C is image of 4. 4 has unique image. So in a set A, every element has unique image. That's why it is a function. Correct now? Check it now. Here 4 elements are there. Each element has unique image. Correct? For 1, there is only one image A. For 2, there is only one image A. For 3, there is only one image B. For 4, only one image C. So it is a function. I will write one more example. A, B. 1, 2, 3, 4. Here also I am taking A, B, C, D. Is it function or not? Check it first of all. What is the definition? Every element of first set has unique image. Here 1 is the element in first set. 1 is related with A, 1 is related with B. So a element in A has two different images. From definition, element of A has unique image. So every element of first set should be contains unique image. But for element 1, there are two images. So it fails the function condition. So it is not a function. Go for another one. 1, 2, 3, 4, 5. A, B, C, D. I'm taking like this. Is it function or not? It is not a function. Why? Why it is not function? Because what is the definition? Every element of first set has unique image in second set. So what are the elements in first set? 1, 2, 3, 4, 5. 1 has image P, 2 has image A, 3 has image C, 4 has image D. But 5 is not related with any element. Therefore, 5 has no image. 5 has no image means it fails the condition. What is the condition? Every element of first set should contains unique image. But here, the element is there in the first set, but it don't have any image in second set. That's why it is not a function. Clear? Next, domain, range, codomain. Just like relation only. In relation already we defined. Okay, we studied about domain, codomain, and range also. Now we will discuss domain, range, and codomain in functions also. First of all, f a to b is a function. First of all, it should be a function. Then the set capital A is domain. The set capital A is called domain. Next, range. Set of all f images. Set of all f images is called range. Codomain. The set B. In relations also, the second set B is codomain. Here also, the second set B is codomain. Yeah. Try to understand. I will explain by taking example. Domain. The first set is called domain of the function. First of all, it should be a function. F a to b is a function. Then the set A is called domain of that function. Next, range. Okay, what is range? Set of all f images. Set of all f images is called range. Codomain. The second set B is there. The second set is called codomain. I will explain by taking one example. A, B, 1, 2, 3, 4, 5. A, B, C, D, E. First of all, is it function or not? Yes, it is a function. Why it is function? Every element of first set has unique image. Check it now. 1 has only one image. 2 has only one image. 3 has only one image. 4 has only one image. 5 also having only one image. Means each element of first set has unique image in second set. So it is a function. Clearly, it is a function. Now go for domain. What is domain? The set, first set, total first set is called a domain. So what is first set? 1, 2, 3, 4, 5. Range. What is range? Set of all f images. What are the images now? A is image. Why A is image? It is related with two elements. Whatever it may be, it is image. A is image of 1, A is image of 2. Whatever it may be, A is image. Here, B is also image 1 because B is image of 3, B is image of 4, C is also image. So, these three elements are images. So, we have to write these three elements in the form of set. That set is called range. So, A, comma, B, comma, C. This is range. Next, what about codomain? What about codomain? What is codomain? The second set, total second set B is there, that is codomain. So, what is second set? A, B, C, D, E. Check it. Domain A. Range is generally denoted by F of A, F of capital A. Codomain is generally denoted by B. Observe, range is always subset of codomain. So we can write F of A is subset of B. Here F of A is range, B is codomain. So range is always subset of codomain. Now we will discuss some standard functions. Some standard functions are there. We will discuss first modulus function. Modulus function. What is modulus function? A function f r to r. Here r is real numbers. A function f r to r is defined by the function f r to r is defined by f of x is equal to mod x, which is equal to minus x if x is less than 0 plus x if x is greater than or equal to 0 is called a modulus function. A function f r to r is defined by f of x equal to mod x. This is simple. Its meaning mod x equal to either minus x or plus x. When we get minus x, if x value is negative. When we get positive x, if x value is positive. Okay. So graph of this function should be like this. X-axis, y-axis, origin. So the graph of modulus function should be like this. When we get like this, mod x is equal to minus x if x is less than 0. So shall I take minus 1? If x value is minus 1, what is mod x value? Minus of minus 1, that is 1. So if we take minus 1, we will get 1. If we take minus 2, x value is minus 2, then mod x value minus of x means minus of minus 2. Whatever it may be is plus 2. Okay, if x is positive, it is as it is. Okay, if x is 2, answer is 2. If x is 3, mod x also 3. If x is minus 3, mod x is 3. So the graph should be like this. This is modulus function. Domain. What is domain of function? Already we discussed. The first set is called domain. Here, what is the first set? R. Next, range. What is range? Set of all f images means result. Result. What is the result? The graph of the function is above the origin. Above the origin means the minimum value is 0. The maximum value stands to infinity. So the range of this function is 0 to infinity. Okay, 0 is included. Okay, infinity is not a particular number. So it is a maximum value. It cannot be closed. It is always open. So closed interval 0 to infinity is the range of modulus function. Next, go for signum function or sinum function. Signum function or simply translated as sinum function. A function f r to r. A function f r to r defined by f of x is equal to minus 1 if x less than 0, 0 if x equal to 0, 1 if x is greater than 0. This is the definition of signum function or sinum function. A function f r to r defined by f of x equal to minus 1 or 0 or 1. When we get minus 1, if x values are negative, we will get minus 1. If x value is 0, function value also 0. If x value is more than 0, f of x value is 1. So how the graph of this function? Check it. Okay. At x equal to 0, what is the function value? 0. 0 comma 0. So first element. If x value 0.1 means x value more than 0. What is the answer? 1. So if x value 0, 0.1. So x value 1, answer is 1. X value 2, answer is 1. X value 3, answer is 1. Why? Means for every positive values of x, f of x value is 1. So from right side of origin, all the values approaches to 1 only. Okay. So it cannot touch us here because at 0 answer is 0. It cannot touch here. No? That's why keep open. If it takes negative values on left side of origin, if I take x value is minus 0.1, if x value is negative, f of x value is minus 1. So I am taking minus 0.1, x value is minus 1. If I take x value is minus 1, f of x value is minus 1. X value is minus 2, f of x value minus 1. Because for every negative value of x, f of x stands to minus 1. So for all the negative values of x, its value approaches to minus 1. So it cannot touch us here. Doesn't keep. This is the graph of signal function. Okay, you can guess what is domain. Domain of this function is R, because already I told them domain of function is nothing but first set is called domain. Next, range. Range is nothing but result. What is the result now? So we are getting 0, 1, minus 1. Only 3 values are we are getting. In result, we are getting only 3 values. One is 0, other one is 1, other one is minus 1. So what is range? 0, minus 1, plus 1. Okay. Next. Next, identity function. Identity function. A function f r to r. A function f r to r defined by f of x is equal to x for all x belongs to r. This is called identity function. A function f r to r is defined by f of x equal to x for all x belongs to r. Is called identity function. So what is the graph of this function? So, try to understand. So if I take 0, f of 0, 0. I am taking x value as 0, the answer is also 0. 0, comma. If I take x value 1, f of 1, 1 only. By taking x value 1, result is also 1. So 1, comma 1. If I take x value as 2, f of 2, answer is 2. 2, comma 2. If I take x value is minus 1, f of minus 1, answer is minus 1. F of x equal to x means whatever you can take real number, the result is also the same real number. I am taking minus 1, answer is also minus 1. I am taking minus 2, answer is minus 2. So the graph is a straight line which is passing through origin. A straight line which is passing through origin. This is graph of identity function. What is the domain? What is the domain of this function? Or only because already I told you, the set, first set is a domain. What is range? Result. Range, result. So it is graph only. So observing graph, x values are approaching to infinity. Correct answer. Y values, the graph of this function approaching to infinity, as well as downside also. It tends to minus infinity. So the values, resulting values are minus infinity to plus infinity. So the range is also minus infinity to plus infinity. Simply we can write R, real number set. Okay. Now, constant function. Constant function. A function f r to r is said to be constant function if f of x equal to c for all x belongs to a function. Simply we can write like this also. A function f r to r defined by f of x equal to c for all x belongs to r. What is the meaning of f of x equal to c? You can take any value, the result is always c only. By taking any real number, f of x, what we can substitute, that is domain. What we are getting, that is range one. So f of x equal to c. By taking any real number, x is real number. So for any real number, the answer is always c only. So how the graph is? Try to understand. X-axis, y-axis, origin. So let us take here to here, c. So whatever it is, 1, 2, 3, 4, 5, 6, whatever it may be, any constant, that constant length I am taking as c. See here, first substitute 0. At 0, what is the answer? C. Next, at 1, answer is C. At 2, answer is C. At 3, answer is C. Whatever you can take any value, the answer is always C. By putting any values on x-axis, we are getting the same answer C. By taking minus 1, x value is minus 1. What is f of x value? C only. Taking minus 2, see, minus 3, see, whatever it may be. So the graph of constant function is a straight line. The graph of a function is a straight line which is parallel to x-axis. So the constant function is a function, its graph is always parallel to x-axis. So if c value is negative, it comes downside of positive x-axis. Okay, now whatever it may be, domain. What is domain of this function now? R only first slide. Range, the result. What we are getting now? Only one value. For every substitution, we are getting only one value. That is C. Set C. Domain is R, range is C. Now, go for next definition. Greatest integer function. Greatest integer function. It is also known as step function. It is also known as step function. See, try the function. A function f r to r defined by a function f r to r defined by f of x equal to box x for all x belongs to r. Here, box x is a greatest integer. It is a greatest integer which is less than or equal to x. This is the definition of greatest integer function. A function f r to r defined by f of x equal to box x. This is a symbol. What is the meaning of this symbol now? It is a greatest integer. It is a integer. How it is now? It should be a less than or equal to x. I will explain now. See here, 3.4. What is box 3.4? So what is the meaning of box 3.4? Box 3.4 is a greatest integer which is less than or equal to 3.4. Here, this is 3, 4, 5, 2, 1, 0, minus 1 like this. Where is the 3.4? It is like this only. It is in between 3 and 4. So what is the meaning of box 3.4? It is a greatest integer which is less than or equal to 3.4. So what is the greatest integer which is less than 3.4 now? So what are the integers which are less than 3.4? Here 3.4 is there. What are the great integers now? 3, 2, 1, minus 0, minus 1. All these are the integers which are less than 3.4. So in that, what is the greatest thing? 3 only. So the answer is 3. Next, I'm taking box 4. What is the meaning of box 4? Here 4 is there. Na? What is the definition? Box 4 is a greatest integer which is less than or equal to 4. So here 4 is also integer. So 4 is integer, less than 4 also some integers are there. Ma? In that, what we have to take? Ma? So the greatest integer. What is the greatest integer? Less than or equal to 4? 4 only. 4 is the greatest integer which is less than or equal to 4. I am taking minus 2.5. Minus 2.5. Check it now. Here minus 2, minus 3, minus 4. Where is minus 2.5? Here only. This is minus 2.5. What is box of this value? Box of minus 2.5 is nothing but a greatest integer which is less than or equal to minus 2.5. So what are the integers which are less than or equal to minus 2.5? Only minus 3, minus 4, minus 6, minus 7. All these are the integers which are less than or equal to minus 2.5. In that, what is greatest one? 3 only, minus 3 only. So box of minus 2.5 is nothing but minus 3. Okay? Okay. Now we will draw the graph of this function. Just try to understand now. 0, 1, 2, 3. Here 1, 2, 3. Minus 1, minus 2, minus 3. Minus 1, minus 2. Minus 3. At 0 means box 0. 0 only. Box 0 is 0 only. Box 1, 1. Box 2, 2. Box 3, 3. Correct? box -1 only. So box -2 only. Now already we discussed number. Box 4 is nothing but 4 only. Na? If it is integer, we will get same answer. If n belongs to z, so we will get same answer. So if I take -3, answer is also -3. Just to try to understand. No? I am taking 0.1, box 0.1, 0, box 0.2, 0, box 0.99999 also 0. At 1, answer is 1. At 1.1, 1 only. At 1.2, 1 only. At 1.99999 1. At 2, answer is 2. It doesn't touch here. Similarly, like this. So we can draw all the values now like this. This is called a greatest integer function. It's just like steps on. That's why we call it as step function. Okay. Now, what is domain? So for this all standard functions, domain is always R only. Okay. Next, range. Range. What are the result? Range is nothing but what is result? What are we getting? 0, 1, 2, 3, -1, -2, -3, -4. 4, 5, 6. What are these now? 0, 1, 2, 3, 4, -1, -2, -3. These are integers only now. So we are getting only integers. That is, range is integer set. Next, a polynomial function. Polynomial function. A function f R2 R defined by a0 plus a1x plus a2x square plus so on an x power n is a polynomial function. It is a polynomial function in x. Here a0, a1, a2, so on, an belongs to some real numbers. These are real numbers. Here n is not equal to 0. If n not equal to 0, then we can say it is a polynomial of degree n. Okay, polynomial of degree n. Okay, now we will write one small example for this polynomial. So I am taking f of x equal to x square. It is also polynomial. Why this polynomial? X square can be written like this, 0 plus 0x plus 1x square. How it is? a0 plus a1x plus a2x square. So this is a polynomial of degree 2. Why? Because a0, a1, a2 is not equal to 0. So it is a polynomial of degree 2. So whatever it may be, f of x equal to x square is a polynomial. So now we will draw the graph of this polynomial. So take this like this, x, it is f of x equal to x square. By taking -3, x value is -3, x square value 9. Take x value is -2. F of x value, x square value is 4, -2 square 4. Take -1 square 1. Take 0, 0. Take 1 only. 2 square 4, 3, 9. Like this one. I'm taking some values now. Now I want to draw graph of this function. Okay? See, 0, 1, 2, 3. Here -1, -2, -3. So 1, 2, 4, 6, 8, 10. So 2 units I'm taking. 8, 6, 4, 2. At 0, 0. At 1, 1. At 2, 4. At 3, 9. At -1, 1 only in between 0 and 2. At -2, 4. At -3. So the graph should be like this. It is a parabola symmetric along y-axis. Okay, positive y-axis. It is a parabola symmetric along positive y-axis. Domain. It is R only. Range. Range is also, we can write 0 to infinity, because all the values we are getting from 0 to infinity, including 0 also. Otherwise, we can write like this option: x such that x square such that x belongs to. This is the range. Both are same meaning. Next, algebra of functions means how to add two functions, how to subtract two functions, how to multiply two functions, how to divide two functions. Algebra of functions. F is a function from x to r, y is a function from x to r. If two functions having same domain, then only we can add, we can subtract, we can multiply, we can divide. Otherwise, it is not possible. So that's why I'm taking f is a function defined from x to r, another function I'm taking g is a function from x to r. Both the functions are defined from x to r. Domains of these two functions should be same. Then only the algebra of functions is possible. Now, f plus g of x can be written as f of x plus g of x. Sum of two functions. So f plus g of x, if f is function, g is also another function, both the domains are same, then f plus g of x is defined by f of x plus g of x for all x belongs to capital X. Next, same f minus g of x also we can write as f of x minus g of x for all x belongs to capital X. Next, f into g of x also written as f of x into g of x for all x belongs to capital X. And that is x belongs to domain. Next, f by g of x can be written as f of x by g of x provided g of x should not be 0. Okay? G of x should not be 0. Now one more concept is that k into scalar multiplication of a function. K into f of x. So we can take k outside directly. K into f of x. So we have to apply for function only. We can take constant outside directly. These are the algebra of functions. Some important concepts are there. How to calculate domain for some standard functions. So some functions are there. If the function is like this, f of x equal to root x. So how to calculate domain? How to calculate domain for this function? Compulsory, the inside value must be greater than or equal to 0. Can we agree? Because root can take only positive value. If it is negative, it is complex number. Na? So because all these are the real functions, so inside value, root inside value must be always positive or 0. Next, if it is in denominator, root of f of x form. If it is in denominator, root of f of x form, then f of x must be greater than 0. F of x must be greater than 0. Next, because it cannot be 0 now. 1 by root 0, 0 only. 1 by 0, not defined. That's why here denominator should be like this. We can take root x must be greater than 0. Next, if it is in the form of f of x by g of x. If it is in the form of f of x by g of x, then g of x should not be 0. Okay? G of x should not be 0. So I will explain some examples now. Then we will discuss another concept also. So if the function is like this, f of x equal to root of x minus 3. What is domain? Domain is nothing but we need to calculate x value. That is what we can substitute, what we can put, what are the input values. That means, first of all, it is in the form of root function. Root function means the inside value must be positive. Correct? X minus 3 is greater than or equal to 0. X is greater than or equal to 3. Here 3 is there. Na? Greater than means right side. So what is the domain mark? 3 to infinity. X belongs to 3 to infinity. So see here, if the function is like this, 1 by root x minus 7 or x plus 7. If it is like this one, it is in the form of 1 by root function. If 1 by root function is there, so the inside value must be greater than 0. The root of function value is the inside value. That one must be greater than 0. Okay. X plus 7 is greater than 0 means x is greater than minus 7 only. Na? So here I'm taking -7. So greater than means right side, this part. So what is domain 1? -7 to infinity. Here 7 is not included because only greater than is there. Equality is not possible. That's why x belongs to open interval -7 to infinity. That is domain. If the problem is like this, x square plus 3 by x minus 1 into x minus 3. Of x equal to x. What is domain of this function? It is in the form of f by g, something by something. So two functions are there, like this, f of x by g of x. So in this case, the denominator should not be 0. Correct? Now? X minus 1, not x minus 1 into x minus 3 not equal to 0. So x is not equal to 1. X is not equal to, correct? Now? X is not equal to 1, x is not equal to 3. Means we cannot put input values 1 and 3. So we can substitute every value except these two values. Correct? Now? So what is the domain one? So we can substitute our total real numbers except these two values. What are those two values? 1, 3. It is not a interval. No? These two are the elements. Okay. Thank you, ma. We will discuss remaining later.